Chapter 16, question 167. 1-chloro-2-methylbutane reacts with sodium cyanide in ethanol. Okay, what is most likely the intermediate or transition state in this reaction? First of all, I would like to draw the structure of 1-chloro-2-methylbutane. Okay, and the reason why I'm doing this is because I want to know 1-chloro-2-methylbutane is a primary or tertiary halogenal alkane. Butane, 4 carbon atoms, 1 chloro, okay, put Cl on the first carbon, 2 methyl, second carbon, there's a methyl group. Okay, the rest will be hydrogen. Okay, now I'd like to simplify this to CH2. H here, another 2H. Now let's look at the carbon that is bonded to Cl. Okay, it is also bonded to one R group. So this is a primary halogenal alkane. Now, if primary halogenal alkane, this nucleophilic substitution will use the SN2 mechanism. Now, what is a SM2 mechanism? SN2 mechanism, okay, the nucleophile, okay, the nucleophile will actually attack. In this case, the nucleophile is a cyanide ion. So this nucleophile will attack the partial positive carbon, okay, from the opposite side of the halogen atom and form a transition state. Now, what's the reason that it will form a transition state or it will undergo SN2 mechanism and not SN1? Is because this carbon is only bonded to one R group. So there is space for the nucleophile, okay, to attack the carbon. Now, if you have a tertiary halogenal alkane, 3 R groups, too bulky, there's no enough space, no gap for the nucleophile to attack the carbon, then in SN1, if it is SN1, then the halogen atom must leave before the nucleophile can attack. But because this is a primary halogenal alkane, it has gap for the nucleophile to approach the partial positive carbon. So a transition state like this will form. See, we are not getting a carbocation ion, so C cannot be the answer, D cannot be the answer. Now, transition state can be A or B. Now, let's check here. If you have a carbon like this, cyanide ion is attacking from here. This carbon will form a transition state where the C is bonded to Cl, okay, but this bond is partially broken, bonded to 2H, okay, bonded to the Cn. Okay, this bond is partially formed, and then you have the very big R group here, C. Okay, C bonded to H, bonded to CH3. Okay, bonded to CH2, CH3. So we check A and B. Which one matches this structure? Oh, sorry, I forgot. We also need to put a square bracket. Overall, it has a negative charge. C bonded to H, bonded to H, bonded to Cn, bonded to Cl, bonded to this big R group. Okay, correct. Now B bonded to it's not bonded to 2H, so B cannot be the answer also. The answer is A.